Oh, I already lost my pen. Okay. So functions. Now you'll notice up here, the first part we're going to do is notes. The rest we're going to kind of do as a homework type thing. So, a function, what it actually is, kind of a relationship between input and output. Actually, between x's and y's, where there's one of each. So my x values got to be different from each other. If they repeat, it doesn't quite work for me. So now, for instance, okay, when I have ordered pairs, my first number in there is always going to be x. My second number, of course, because we've been doing all this with slope, is going to be y. So, when I'm trying to figure out if this is a function or not, I'm looking at the x values. Because you'll notice right here, it says the x values must be different. So if I look at all my x values here in my first example, are they all different? Well, I might want to take one more look. Okay, what happens, or what I notice is, yeah, I see 2 gets repeated. Okay, if I have any of them repeat, any of them at all, that's not a function. Because if I were to graph all of these, and that's actually what we're going to do here in a minute. Ooh, excuse me. Okay. We're going to kind of play with it. So if I visually can see, if I go and graph these, so 2, 1, I'd go right 2, and up 1. Okay, and then I've got 3, to the right 3, and down 2. Then I've got negative 3, good. To the left 3 and up 1. And then to the right 2 and down 2. Now you're like, okay, so I got all these points here. Okay, so what? When I'm looking at these graphically, if they plot all the points for me, if they draw me a picture, okay, for it to be a function, it must pass what's called the vertical line test. Okay? So, if I'm trying to pass the vertical line test, which is a line that goes, whoops, move that up a little, that goes up and down, if I go anywhere within the graph, and I draw a vertical line that goes through more than one point, yes, sir? Negative 3 and 1, yes. And then, what other one? That's okay. So if I could go anywhere in the graph and draw it up and down, a vertical line, and it goes through more than one point, it's not a function. So in this case, if I draw a vertical line right here, it goes through 2 points. Okay, so just like we saw when we did it just looking at the points themselves, it ended up just being not a function. Okay, it doesn't pass my test that way. Now, there's one other. Okay. There's one other way I can look at these to try and help myself out. There's one other way they'll basically be written. And that's either with these ovals or with a T-chart. So here's how this would work. If they're in the ovals, basically I would just take the x values that I have, I'd copy them into the oval, and then I'd take my y values, and I'd have the same thing. Now here's the nice thing about visually seeing them. Okay, we already know it's not a function. We've already figured that out just looking at the points and looking at the graph. But now again, I can look within that oval and again see if any x's repeat, it doesn't work. Okay, it's not going to do anything for me. Same thing happens if I were to look in a chart. We're just looking to see if the x values repeat or not. Okay? So here's how this works. When I'm trying to figure out, this is just kind of what's going on in general, Are the following graphs functions? I'm going to zoom out a little bit here. Maybe. So we can actually see a little more at once here. Yes, sir. Right. The y's have no real impact on whether we're a function or not. It's all about x. So on these functions, okay, is there any place in number 1 that I can draw an up and down line and it'll go through more than one place? Let's see. I don't really see any. So I'm going to draw a vertical line through. Anywhere you want to. If you wanted to draw it over here, you could. And if it only goes through at one point, then yes, it ends up being a function. And that's going to be true on any of these. Now, I can go right down the middle. Still only one point right here in the middle. Oh, now see, I like this thinking. But what if I chose to come over here? It's not a function. So I don't want to just look for the place that would be the exception to the rule. If I can find a place where it does end up being more than one point, in this case 2 points, it's not a function. Anything more than 1, even if it's the one possible and only place. So let's see. Is there a place anywhere on 3? Now and I'm hearing no. Okay, so again, even if I wanted to, let me kind of go with my sticky note here. If there's ever a time where I see my sticky note would be getting 2 of those dots at the same time, it would be no. But it looks like, here, no matter where I go through, I can pick one. There'll only be 1 point. So that's going to be a function. That's a yes. But I'm hearing the next one, you might not be so lucky. So let's see here. That's only 1. That's only 1. Oh, right there. See, right here, if I make my line, it's going through 2 points. And if it goes through any more than 1 at all, it ends up being not a function. Oh, 2 points, yes. Oh, hard mercy. 2 points, definitely not a function. Not a function. Okay. So with graphs, vertical line test kind of makes us are good or not. When we're looking at just the ordered pairs, okay, x is the only thing that matters. Do any of my x's repeat number 5? No, they're all different, which makes it a function. That's the only thing you have to look at. Just the x's. If they do not repeat, it's a function. If they do repeat, then it's not a function. So like in number 6, do any of my x values repeat? Yes, 5 does. So 5 repeats, so that makes it not a function because it wouldn't pass the vertical line test. Tables work just the same way. Okay, my x values will always come first, and then my y's. And again, I'm just looking at the x's. And if I see any that repeat each other, like the 3 does here, it's not a function. But if I look at all the x's, and I don't see anything that repeats, it is a function because none of my x's are the same. They're all different. The y's, again, do not matter. I know the y's kind of feel bad about that, but that's life. So you're kind of seeing here, not a lot of work. It's just understanding a couple of basic concepts is what we're looking for. Flip over. Okay, I'll tell you right away, no, we're not doing the bookworks. I know some of you will look ahead and say, oh, what? No, we're not. So here, I look, and I go, okay, You're like, now what's this domain and range thing? Okay? Domain's just a fancy way of saying your x values. Range is just a fancy way of saying your y. Because, yeah, basically what they're doing here is they're giving you the coordinate points, just like we were before. So if 1 goes to 2, this would be the point 1, 2. If 2 goes to 4, and it is because if I write all my points down, I don't have any x's that repeat, 1, 2, and 3. So this is most definitely a function. And you're right, because if I wrote my points down here, 1, 2, 2, 4, 2, 6, I have a problem. I have a repeat of my x's, so that one would be no. Now, this next part, we're basically going to be doing some substitution, is how this is going to work. So here's how these go. Whatever numbers in the parentheses get substituted in. So this is like saying, let x equal -2, and the letter in front tells me which expression to plug it into. So like here, f of -2 means I take 3x minus 8, okay, the expression that's there, but I'm going to replace the x with the number that's in parentheses. So x gets taken out and replaced with the number inside. Okay? The f part we don't do anything with. We're just looking at the expression, and then 3 times 2 is -6 minus 8 gets me to my answer. Kind of weird, huh? Now, well, right, yeah, what if they don't give me a number? Like number 12, I don't even get a number. What's up with that? They want me to do g, okay? Yeah, all I'm going to do is replace the variable with what's in the parentheses. n squared plus 6. I can't solve anything. They didn't give me a number. But I can change the variable. Okay? So again, whatever's in the parentheses is what you plug in. And it gets kind of strange sometimes. So then I get to f. Okay, so here's f. So 3 times, oops, there's x, whatever's in the parentheses goes in for x, and I repeat everything else. Because this is really 3x minus 8, but what I'm going to do is I'm substituting m plus 2 for where the x is at. Now this one I got to do a little bit of work. Yep, if I see the parentheses, I have to distribute. Can I do anything else for this one? Yeah, I can combine the like terms. So 6 minus 8 is -2, and that's what my simplified form is going to end up looking like. So again, whatever's in the parentheses, let the letter tell you which equation, or which expression in this case, and then this just goes in where that goes. So here, I'd have 3. Again, whatever's in the parentheses goes in for x. And then I just simplify what's left. 2 times 4 would be 12t minus 8. Can't combine these. This has t, this doesn't. I'm done. Like, okay, maybe. Ah, that's coming. 15, you're like g of m. Now, what's this plus 2 thing? Okay, don't worry about the plus 2 quite yet. G of m just means I'm going to plug in m where x is. So m squared plus 6. And then the plus 2 just gets tacked on at the end. And just like we had in number 13, if I have like terms, I'm going to go ahead and put those together, and I'm ready to go. Then, like Michael said, what happens if I have two of them? Okay, here's what we're going to do. I'm going to cover up the first one. I'm just going to do the f of 4 part first. So here's my expression. So 3, whatever's in the parentheses, goes in for x, minus 8. So 3 times 4 is 12, minus 8 is 4. Okay, that's my first part. Once that's done, flip it over here. So now I want g of negative 4. So here's this. So we've got negative 4 squared plus 6. So I replace the x with negative 4. Negative 4 squared, in other words, negative 4 times negative 4 is 16 plus 6 is 22. Now, since I have the numbers, I can actually get to an answer. But it's like doing two problems in one, basically, is what we're going to do on that one. And it just kind of keeps running with that pattern. F of negative t. Okay. Replace the x with what's in the parentheses. Negative 3t minus 8. And I'm good there. F again, so we're using this one. 3 times, oops, there's an x. Use what's in the parentheses. Okay, don't forget about the minus 8 on the end. Just don't think when I substitute I'm done. I got to finish it off. And then again, similar to what we did in 13. Distribute to both terms, not just the first one. And combine like terms. And then, of course, we have to throw the weird one in at the end. Oh, no, it's supposed to be there. Okay? When you do this, again, this is about patience and doing parts at a time instead of trying to do everything at once. Okay? F of d means I would replace the x with a d. Okay? That would be the f of d part. But then, I'm supposed to multiply whatever this is by 4. Little bit of distributing, absolutely. And I'm good. So, here's what we are going to try out. Down at the bottom of this page, we scratch the book part. We are going to scratch number 4 down at the bottom of the page. Because that's not one of the ways we're going to deal with our functions right now. Okay. The rest of this is stuff that we just did a ton of examples for. So your job is to finish this off. Use the ones that you've got examples of that are similar to try and finish the rest of these. And if you're getting stuck at any point, or maybe you missed some of the ones that you're doing with the examples, let me know. I can get to this. We can get you caught up with those. But otherwise, we're going to do this. And then what we'll have coming up